In this video, I will be demonstrating how to do rim space analysis in uniTank. First off, I want to show how auto-classification works when a floating roof is present. Just like for an internal tank with no floating roof, you just need to define the shell bottom and top circles. When you run auto-classify, make sure the floating roof checkbox is clicked and uniTank will do the rest. Once the tank has been classified, you can see that the top side of the floating roof has been correctly identified. Before we do the rim space analysis, we want to reclassify some of the shell points near the floating roof seals. These transition areas are not clearly visible and will create discontinuities in both the shell and rim space analysis. Where you will see it most is in the banding analysis. So what I'm going to do here is estimate the upper and lower bounds of the floating roof seals. Then I will classify all shell points within this area to others. Now, we are going to move on to the rim space analysis. We need to estimate the floating roof outer rim. If it is not clearly visible in the scans, you can use the foam dam or the inner rim. You will just have to specify the distance between the reference structure and the floating roof outer rim during analysis. In this tank, we can clearly see the outer rim. It will be in the Others class. We will isolate the cleanest horizontal slice of the reference structure, whether it be the outer rim, inner rim, or foam dam. If visibility of the reference structure is spotty or the floating roof is not level, you may need to use different horizontal slices in different areas of the tank. We want to classify the points in the horizontal slice as floating roof rim. If you are using multiple elevations, you will have to classify the points at each elevation separately. Then, we want to remove as much of the inner structure as possible to isolate the reference structure. We will run automatic cleanup of the reference structure, reclassifying all points inside of the reference structure to others. Finally, we will use the floating roof rim class to trace the floating roof. We want to inspect the floating roof definition to see that it accurately follows the reference structure. If there is noise in some areas, or areas where the reference structure is not clearly visible, you can repair the floating roof definition by drawing a new line in the area and redefining the floating roof definition in that area. Notice that only the area that you have redrawn will be replaced. Before we do the analysis, we want to make sure we have the properties correct. If this is an internal floating roof, make sure you identify this in the properties, because there are different verticality requirements for the columns and shell when an internal floating roof exists. When we do the analysis, you will need to input the seal tolerances. If there is only a single seal, Just enter the same tolerances for the secondary seal as you did for the primary seal. In the analysis, you will have two sets of results, an as-scanned rim space and a roof-centered rim space. In most cases, these results will be very similar. Where you will see a difference is if the floating roof is misaligned. Finally, we can do a floating roof deformation analysis. In most cases, the floating roof will be out of service and resting on supports. However, if the floating roof is in service, this analysis will indicate whether the floating roof is level or not, and where there are bulges and depressions.